the next screen. Uh-oh, that's not good. There we go. So we're going to do this in 3 parts. Part 1 is all about noise and how to mitigate it. And then we're going to look a little bit about how to characterize your own RFI environment. And follow that with a live demonstration. We're actually going to track noise and look at some things that are noisy and things that aren't noisy using a low-cost SDR software-defined radio, and also just a cheap AM radio that I picked up at the Goodwill store. So the question is, what will you learn today? And hopefully you'll learn something that you'll be able to use. So the first thing we do is talk about what is noise, right? In radio terms, noise is a signal that comes from sources other than a transmitted signal source. It also really doesn't convey any information. It's of random frequency, amplitude, and a random pattern as well. And electrical noise is defined as an unwanted electrical signal that falls anywhere within the passband of the receiver. So anything that's noise, electrical noise that falls outside the passband isn't really noise. But the question is, what's the passband on the receiver? We're going to talk about that in a little bit. And keep in mind that noise can either be internal, as in generated within the radio itself, or external and come from an external source. An internal source of noise, for example, there's noise caused by transistors, and tubes have thermonic emissions within them that causes noise. And there's also external noise, and we're going to talk about some of the sources of external noise particularly. And keep in mind that noise is not to be confused at all with interference. They're really 2 different definitions. Interference is defined as a form of external noise, which means to disturb or detract from. And it's really when information that's supposed to be in one place winds up being someplace else. In other words, for example, it's supposed to be on 40 meters and it winds up being on 20 meters. That's considered to be interference. Or it's supposed to be within a designated bandwidth. For example, say a 3 kilohertz wide single sideband signal, and it winds up being 4 kilohertz away. That can be considered to be interference. Examples of these are splatter, right? Extra wide signals. We've all run into those, and especially in contests. CW key clicks, transmitters that have extremely fast rise times on their transmitted signal will wind up having what are called key clicks. And of course, harmonic interference. And that used to be a big problem in the old days. It's not quite as much of a problem now, but that's considered to be interference. Once again, not to be confused with noise. Different types of noise. There's natural noise, right? Noise from our sun, noise within our own atmosphere, and of course, noise from outside of our solar system. It can be either man-made or industrial noise. And there are some types of noise that we can control. If you've got a noisy power line or a failure or an arcing on a transmission line, that can be repaired. But unfortunately, there are some noise sources we just can't get to the bottom of. And of course, a little barking dog in the middle of the night can definitely be an example of that. So let's talk a little bit about natural or solar noise. The sun, by the way, due to how hot the darn thing is a huge wideband RF source. It basically puts out everything from, 1 kilohertz noise all the way up into the microwave and then beyond into the gamma rays, X-rays band, and it's broadband. There are 3 components of this solar noise. One of them is called the background noise, and this is the normal noise that the sun does just because it's so hot. There are different areas of the sun that are different temperature that emit different levels of noise and frequencies of noise, and that's called the slowly varying component. And of course, the one that affects us all the time as amateurs are what are called the burst component, which are our coronal mass ejections, or they're known as CMEs. You'll hear them called CMEs, and of course, solar flares. And those things not only have a huge problem with noise, but also are what cause our propagation to occur here on Earth. And of course, there is also noise coming from other planets and other galaxies out there. If you have an antenna and a noise level at your own house that's wide, that's narrow enough, you may be able to go out in the middle of the night and aim your antenna at the Milky Way and actually watch your noise level rise as you're looking at noise coming from the rest of the universe, or the rest of the Milky Way at least. So let's talk a little bit about atmospheric noise. Atmospheric noise can be thermal noise just from our own atmosphere. Our own atmosphere, because of the electrons and the atoms moving through their magnetic field, or Earth's magnetic field, that can cause thermal noise, or noise, but coming to and affecting our propagation. The largest single source of noise on the planet is lightning. there are approximately 3.5 million hits per day of lightning. And that noise being, once again, a broadband in nature, can travel all around the world. And that's the single largest source. There's also a thing that I've run into, a thing called snow static. And these are smaller electronic discharges as snowflakes come down through the air, especially if it's a fairly dry air. You can actually pick up a electrostatic charge, and it will discharge that charge on your antenna elements. One time I was in the middle of a contest here a couple of years ago, and all of a sudden my noise level went from S2 up to 20 or 30 over 9. I couldn't figure out what the heck this sudden noise increase was. I looked outside and saw it was snowing. And sure enough, that was a great example of snow static. Some of you people in the drier areas with snowstorms may have experienced this. And one thing to keep about atmospheric noise, it's mostly of random frequency because it is so broadband, and it's also random polarization. It's not really horizontal, not really vertical, but some mixture, and it changes all the time, and that makes it extremely hard to mitigate. Keep in mind also, and this is an important point, the field strength of atmospheric noise does vary approximately by the inverse of the frequency. The higher the frequency, the lower the atmospheric noise. So 160 meters will be our noisiest band. If you get down into the 400 kilohertz, 200 kilohertz band, it should be even noisier. 80 meters is somewhat less noisy, and you work your way up to 10 meters. And 10 meters, you'll notice you won't hear a lot of noise on there. Because most atmospheric noise, as I mentioned, is on the low end of the band. And keep in mind that VHF and UHF components of noise, or parts of noise, are basically line of sight, just the same way radio waves are. So they're much less severe above 30 megahertz because they don't follow the curvature of the Earth. Now let's talk about man-made noise. This is also known as radio frequency interference, or RFI. There's noise internal to the radio itself. I mentioned that. There are examples of this, tube noise that are caused by the thermonic action between the cathode and throwing electrons at the plate. And keep in mind that modern SDR radios, because they don't have preamplifiers, they don't have mixers, they don't have a lot of electronics in them before they take care of the signal. They run the signal into a to D converter, and then they process it and they spit it back out in a D to A converter. They suffer much less from noise problems. I've got an older FT1000 Yaesu radio. The first thing you do, turn on, you hear all this noise, and you turn a modern SDR radio on, like an IC7300 or an FT3000. You'll notice you try to turn the audio gain all the way up to hear anything on that radio. It's just amazing how good the modern radios are. Switching power supplies, wall warts, right? Things that we use to power our accessories. These are a huge noise source mostly. And keep in mind, there are good ones and bad ones, right? The good ones are the ones that are nice and heavy and have a transformer in them. And I'm going to show you guys an example of this later. And the ones that are extremely light are generally pretty bad. And we're going to have a demonstration of just how bad they can be. But however, it's best to get rid of these darn wall warts if you can, and run everything off a nice quiet power supply, or perhaps a battery with a trickle charger on it, to power your station off there. But it's best to eliminate them altogether if you can. There's computer and RF hash that goes along with them. We're going to have a demonstration of that later. Remember the old days of plasma televisions? LED streetlights are a current problem. I live about 25 miles northwest of the city in Portland here in Oregon, and I live in a fairly rural area. And when I point my antennas towards Portland, my noise can go up a couple of S units on 40 meters. So, and I think a lot of this has to do when they started putting LED streetlights in. Of course, there's the old fluorescent and light ballast. Those can cause a lot of noise. Power line noise, that's one of my big problems here, and probably my main contributor to noise. And of course, LED and grow lights are the newest source of noise, especially for us up here in the Northwest, where growing cannabis is legal. And keep in mind that most man-made noise is mostly vertically polarized when it's in the near field before it can bounce off anything. Most of these man-made noise sources are things we can control to an extent, but it's really going after the source, right? If you don't have to worry about mitigating the noise, if you can eliminate it at the source. And there are some ways you can do that, and we'll talk about that a little bit later. However, keep in mind there is no magic bullet, right? Every situation is going to be different. Every noise source is going to be different. And how one attacks it also could be different. To really simplify noise mitigation, it's all about the signal to noise ratio that your receiver hears, right? It's the power of the signal divided the power of the noise. To mitigate it, you either have to increase the level of the signal or decrease the level of noise. That's really how simple it can be. And keep in mind, a lot of radios have noise blankers on them, but these really work best on impulse noise. I've got a pretty good sized property here. I've got a pasture that my horses hang out in, and I've got an electric fence that runs around my pasture, and I get the click, 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 click on there all the time, and my noise blanker, my radio, does a real good job of getting rid of that, but it will not work on atmospheric noise that well, right? It basically works on impulse noise, such as fences or spark plugs, things that go a very low pulse rate. So how do we mitigate receiver noise? Well, we can take a look at our antennas. Verticals are inherently pretty noisy. Yagis are much less noisy, right? They're horizontally polarized, but they're also directional. Verticals are omnidirectional. Yagis are directional, so you can point your antenna more towards the signal, right? Increase the level of signal, and you can also turn it to null a noise source. So there are two different things you can do with the Yagi. Ensure you have proper bonding and grounding of your equipment. Right, there's a really nice ARRL book you can get on that, but make sure everything's bonded and grounded to keep a common mode noise to a limit. Jim Brown, K9YC, who, by the way, won one of our technical service awards last year, has a really good website that talks about the use of ferrites, and I'll have a reference to that at the end. If you do buy ferrites, the best ones to get are what are called Type 31. Don't get 72 unless it's a really low frequency one, but these things are pretty frequency. There are some frequencies that work on better than others, and for the HF ham bands, the Type 31 is the type to get. And really learn to use the controls on your radio, right? A lot of us buy a new radio, we turn it on, we plug it in, especially for a new ham, and you're kind of, in that case, you're really kind of your own worst enemy. But we're going to talk a little bit about some of the controls on your radio that will help you mitigate receive noise. If you can, move your antennas away from noise sources, and that's not always feasible, especially if you're on a small lot, but you could always try moving it away, and we're going to talk a little bit about that in a second. I've got 2 towers. I'm lucky that I live on a property here where I can put towers up, and I've got 2 towers that are about 300 feet apart. One is right by my house, right by my radio room, which is in a building outside my house, and one of them is back by my barn and about 300 feet away. And there's probably 2 S units of noise difference between those two antennas. They're pretty similar antennas. And the main reason is there's no, my horses back there don't make a lot of noise, RF noise. So, but my house certainly does. If you kind of a last ditch attempt is to consider using an external noise canceller device. Kind of a magical device you don't hear much about. We're going to talk a little bit about what these are. So here's my situation. This is a picture of my shack, which is inside of a pole barn shop, and there's my tower, and there's my old TH6. I've since replaced that. But what you can't see here, if you look towards the bottom, you can see that there's a power line that runs kind of almost right by my tower. There's a lot of wire antennas up here, and it's very close to some of these wire antennas. So my biggest problem is power line noise, right? It gets picked up by the tower. It gets picked up by the coaxes. So what I found works pretty well is to use common mode chokes on all the low band coaxial feed lines that come in. I don't know if you can see my marker here, but this coil of wire right here is a ferrite solution that I have for my 160 meter sloper arrays. I've got 3 160 meter slopers in 3 different directions, and I use this to mitigate the noise on that. This is from my 80 meter dipole. And so what I do is try to keep the noise from getting inside the radio shack. This happens to be the wire that comes in from my beverage. And so I try to keep the, which is a low noise receive antenna we'll talk about in a minute. So I try to keep the noise out of the shack as much as possible through the use of ferrites. Know your radio, right? Turn down your RF gain, your radio. Every radio's got a volume control, but what I want you to consider doing is consider turning, instead of turning the audio down, try keeping the audio up a bit, but turning the RF gain down. Most radios have an RF gain control, and for sure, certainly turn off preamps, especially on the low bands, 40 to 160 meters. There is no reason to have a preamp on those bands. And if you do use them on, it's all you'll be doing is increasing the amplification of the noise and the signal, and 3 guesses which one works. As a matter of fact, on 80 and 160 meters, consider turning the attenuator on. I find it very useful to use between 6 and 20 dB of attenuation on the front end of my radio. You know, there's a little switch that says ATT on it. And if you're on a low band, especially on 80 and 160, try turning that on. You'll be surprised how much signals will come out of the noise. And the reason for that is the noise is so overpowering. It's overpowering the automatic gain control, the AGC in the radio. So the AGC is reacting to the noise and not the signal. So it's burying the noise and bringing the signal up. By throwing in attenuation, the AGC gets a little bit of reprieve, and you can therefore start hearing the signal instead of the noise. If you've got a radio that doesn't have any IF filtering in it, for example, an old FT1000 or one of the FT1000 MPs, or even some of the more modern radios, consider putting the IF filters in there, right? The more you can narrow that passband of the radio, of the receiver down, the better your noise situation is going to be. If you've got a wider filter, consider putting a narrow filter in there, right? The CW guys know it's a lot easier to pick a signal out that's got a 500 in a 500 hertz filter situation, or even a 250 hertz CW filter, rather than, you know, using a 3 kilohertz filter. If you don't have filters, add them, right? And learn how to use your IF passband or IF shift on some radios. Icom calls it IF passband. Yaesu and Kenwood call it IF shift, and that you use that to narrow your tuning range. And if you've got a radio that's got DSP, digital signal processing, for example, Yaesu has a contour setting and a notch setting, and help use those and learn how to use those. Let's talk a little bit about the passband tuning or IF shift. And these are great things because if you have an interference signal or a noise signal, you can actually try to shift that outside the passband. So right now, if you take a look here, we've got this interference signal, and it's just really close to the signal we want to hear. There's another signal next to it. We can actually turn the knob to the left and move the passband to the left and actually knock the signal out where it's not being heard, and yet the desired signal, we can still get enough of it to tell what it is. So there's one very important knob. I always usually run the IF shift slightly to the left. It gets rid of a lot of noise, and also makes the signal that I'm listening to a little bit easier. Noise is very fatiguing, and especially in a long contest, the more noise you can get rid of by using your controls on your radio, the much nicer it's going to be, and the much longer you're going to last before you get fatigued. You can also consider using some special antennas for noise mitigation, which are, you know, basically receive-only antennas. Here at W7VO, I have I'm very lucky enough. I'd mentioned I live on a couple-acre property. I've got what's called a beverage antenna. This one's a bidirectional one that I bought from one of the major sponsors that advertises in QST. It's a bidirectional one. You can also use a loop to help null out noise, or use that as a low-band receive antenna. And the kind of as a last step is to consider the use of what's called an external noise canceller. And there are several of these on the market. One of them is made by MFJ, but a company called TimeWave makes one. DX Engineering makes one. There may be other ones too that you can see out there, but these things are pretty handy. So how do they work? Well, remember, it's all about the signal noise ratio. If we can get rid of the noise and pull it away from the signal, all that's left is the signal. The way they do this is by using a separate low gain noise antenna. So they use an antenna whose only job it is to pick up noise. And why is it low gain? Because we want the noise only. We don't want the signal. I particularly, I have two of them available to me. One of them is a really cheap, small vertical antenna that I have mounted pretty close to a power pole where my power comes into my house. And I've also got a very steep inverted V. It basically is a old 40-meter inverted V antenna that I had up that's basically laying along my tower. And its job is to pick up noise that gets picked up by the tower. So I have a couple of different antennas. Sometimes one works better than the other one does. If you have a loop, that works well too. You can also use that to null out the signal and mostly pick up the noise. And where the canceller installs is between the radio and the antenna, or the radio and the tuner and amplifier. So you want to have it be in the low path part of the mode. And these things all have built-in transmit receive switching. So they automatically detect when you're transmitting, and they basically bypass the noise canceller when you're transmitting. So you don't have to worry about blowing them up. And the way they work is they feed a reference signal into a mixer at 180 degrees out of phase. And so what they do is they cancel out that noise, leaving the signal intact. And keep in mind, these things really work on noise that has a consistent pattern, which are basically man-made noises. But, I've had them work pretty well, sometimes in atmospheric noise. And it's really made a difference between making a signal or making a QSO and not making a QSO. And keep in mind that both the phase and amplitude has to match in order to cancel the noise. So these things do have controls on them you have to kind of fiddle with to get those two. So the phase of the noise and the phase of the signal are the same, and the amplitude of the noise is the same as the amplitude of the signal. And once again, there's no magic bullet. Your results may vary. You may find that doesn't work for you at all, but it's kind of a, if you're, you can buy these things for $50 at a ham swap, pick it up and try it. And here's kind of a little diagram to show you how they work. You've got the signal and noise coming in one port. You got the noise only, so hopefully coming in a second port, fed through a 180-degree inverter into a mixer, and what comes out technically is only the noise. And once again, that's the way they work in theory. Here's kind of a front end, a picture of a couple of them here. You can see that there's a auxiliary, which is the noise antenna gain, the main antenna gain, so you can match these two and then adjust the phase. The ANC time wave unit, they've got a noise phase, a noise gain. So here there's kind of less controls to deal with. You can also change the phase range. So really it's kind of playing with these controls to get it to where you can knock the noise out. And there's YouTube videos you guys can see to help you with those. Here's how I have them hooked up in mine. I don't have mine in the actual transmit path. I have mine as an adjunct to my beverage antenna input. So I've got the ability to use the noise canceller or use an external receive antenna by using the low noise receive antenna input on my Yaesu FT2000. Now let's talk a little bit about characterizing your noise environment, right? We can kind of move things around to get rid of the noise. Let's see what we can do to get rid of the cause of the noise. You can use one real easy way to track noise sources, especially local ones, is to use a cheap AM radio. I'm going to show you guys how to do that a little bit later. And we know we have this noise, we have this RFI, we know that it's interfering with our ability to receive, but what does it physically look like? Well, to really see it, you have to visualize it. You have to see it with your eyes. And in order to do that, you really need a different perspective than a typical HF radio. And you're going to say, oh, well, my radio's got a pan adapter. Right? Well, pan adapter basically looks at signals after they're processed, after they've been filtered, after they've probably been mixed down, and you're not going to see the noise. They don't want you, when you have pan adapter, they don't want you to see the noise. They want you to see how many signals are on the band. So they kind of filter all that stuff out first. So really, a pan adapter is not the same thing as using what are called an SDR. So what does it take to actually physically see this? And of course, what I mentioned there, it takes an SDR. Well, so what's an SDR? Well, it stands for software defined radio. And keep in mind that most of the radios you're buying today, the IC7300, the new FTDX radios from Yaesu, those are what are called software defined radio. And most of the processing is done with software. They're kind of like the standard radio, but they really use a computer to replace the mixers and the RF amps and all that in there. A lot of these, especially the small, cheaper ones, they basically feed the signal directly into a D to A or A to D converter, basically right off the antenna port. And all the signal detection and formatting are done mathematically, not electronically. And as a result of that, I mentioned earlier, they don't really suffer from as much internally generated noise. Let's talk about actually setting up an SDR. If you do buy one, make sure it covers the frequency range you want. Hint, some of the cheap ones, you can buy a $20 one on eBay. I'm actually the one I'm going to show you here is one of the cheaper ones. It's made by a company called RTLSDR.com. But it basically, the low frequency on it is 28 megahertz, which covers basically the 10-meter band and up. Know how to download, install the software and drivers if they're required. Basically, you connect the radio to your antenna, or you can use, if you want to track internal noise, you can use a loop antenna. We're going to show you guys that in a little bit, or an outside antenna. And if you've got a near AM broadcaster near you, you may want to add a broadcast band filter. Those are readily available from the suppliers. Learn how to use the radio, how to turn it on and get it to do something. There are these SDR specific software packages you can get. I use one called SDR Sharp. It's available for free. And the actual dongle I'm going to show you guys here is an RTLSDR.com dongle. I think I paid $25 for it off of eBay, brand new. But there are many others you can buy, and you can buy ones that are the typical one you'd want to do if you really wanted to get serious about it would be one of the $100 ones made by RF Space and some other companies. Dave NK7Z, and I'm going to give you his reference in a bit. He is our our Northwestern Division Director. He's assistant director in charge of RFI. And he has helped many of our amateurs here in the Northwest solve their RFI problems. He uses an HD SDR software package and what's called an SDR Play RSP1 as the radio. And the radio is about 120 bucks. So let's take a look at some screenshots, right? So the first thing you want to do when you hook up the SDR is get a screenshot. Look at all the different signals that are out there. And here, if you take a close look, you'll see he's looking from about 5.5 megahertz up to roughly the bottom end of the 40 meter band. And you can see all the little blips in the second part down here. These are a graphical representation like a spectrum analyzer, and you've got your waterfall display up here. And the question is, some of these are noise sources, some of these are probably signals. But now let's take a look at a ham band. This is what 40 meters actually looks like at his house. And he's been working for a long time to try to mitigate noise. He's got a horrible noise problem on 40 meters that's being caused by a grow operation. And the reason he knows that's a grow operation, I'll show you in a second. But you can see that here from about 70 all the way up to about 7160 is this huge swath of noise. And these are most likely signals up here. So basically from 7005 up to about 7160 is this huge broadband noise source. And you can see here how dark this is. This is actually taking up all the, taking up the AGC in his radio, and the radio can't respond to very many of the signals that are close to it because this is wiping it all out. And you can also take a look at this thing over time. You notice here that all of a sudden the noise is shifting in frequency a bit as time goes on. These are, I believe, in about 10-minute or 20-minute intervals on the side. And you can see that along at this, the actual frequency of the noise source is changing as time goes on. And all of a sudden, at a certain time, it turns off. At that point, you notice now there's all these signals and other noise sources in here. So this is an example of the AGC being taken over by the noise source. So let's talk about some technical resources, right? One of them I mentioned is Jim Brown, K9YC, has a free publication you can download off his website called RFI Ferrites and Common Mode Chokes for Hams. It's a great resource. It's something that he does for amateur radio to give back to the hobby, and you can download it off his website for free. And he is really the guru on this. I mentioned Dave Cole, NK7Z. He's got his website, and he's our Northwestern Division RFI technical resource. There are also books you can get from the ARRL, not to be a commercial for the ARRL here, but The Grounding and Bonding for Radio Amateur by Ward Silver, N0AX is a great addition to your shack, and I would highly recommend it. And the ARRL also has a couple of RFI related books. One of them is called the RFI book, right? And it's available for purchase. And there's a couple of web pages here that I have listed, and you can get some RFI information, not only about within your own shack, but also information for the neighbors of hams, right? So you can see what they're telling people to do if they're next to a ham and is a cause of noise. So let's go ahead. I'm going to go ahead and shop my screen share now. Let's do a little live demonstration. And hopefully I'll get back to here. So let me shop the screen share. And let me get out of here. And hopefully you guys are seeing that now. Now I can't see, hopefully you guys can see me, I hope.
We can see you, Mike.
Okay, because all I see is my screen, so that's perfect. Okay, so what we're going to do is we're going to do an experiment here. And what I have is I have a very inexpensive AM radio that I purchased at Goodwill. local Goodwill store. And what I've done is I've turned the radio all the way down to the very low end of the band. It's at 540 kilohertz. I'm going to turn it on. And what I'm going to do is take this radio and I'm actually going to put it right next to my laptop. And I want you guys to hear the difference in the noise as it gets closer to my laptop. That's the RF hash that my laptop is generating. And what I have now is I have a power source here. And we talked about these little wall warts. Here's an example of a wall wart. This one's a pretty heavy one. It's got a transformer built into it. And what we're going to do is we're going to plug in and plug it into the AC source here. And it's plugged in, got power. And you notice that I put the radio next to it. There's nothing there. Very quiet. Now I'm going to plug in. Now I'm going to, oops. Cord's stuck here. There we go. Now I'm going to plug in a little light one. By the way, these are all these power supplies I'm showing you guys are all 12 volt, 1 amp power supplies. That last one had a transformer. It was a linear supply. This is a switching power supply. I'm going to plug it in and put the radio up next to it. And hopefully you can hear that. It actually puts out a lot of noise. I can even pull it away and it gets still noisy. So this is a switching power supply. This is what you don't want to use in your shack if you can at all avoid it. Now, just because you have a power supply that is big and big doesn't necessarily mean it's noisy. And I have these two look very similar. This one's fairly heavy. This one's fairly light, even though it's physically larger. This is a switching power supply, but this switching power supply, I'm going to plug it in. And you notice it's a little bit noisier than the one with the transformer, but not a lot noisier. This one is actually designed pretty well. So this one is okay to use in your ham shack. The nice heavy one, the linear supply, is good to use in your ham shack. This one is not good to use in your ham shack. So one way you can test it very simply with just using a cheap radio. Now, the next thing we're going to do is we're going to look at some LED light bulbs. So what I have here is a little light fixture, right? A little automotive light fixture, and I'm going to plug in an incandescent light bulb. And of course, you have to plug it in first. So let me plug it in. Uh-oh, and of course it doesn't work. Why doesn't it work? Oh, there we go. So you can see we got the light bulb here. We're going to hold the radio up to it. And we got a little bit of hash that's coming in from the power cord itself. So I've got some little bit of noise coming from the power cord, but there's a light bulb. Now I'm going to use, this is an LED bulb, one of the ones you can get at the store. I've got 3 different manufacturers here. These are all 60 watt equivalent bulbs. And this one, pretty noisy. If I hold the radio way back here, you can still hear the noise. This one's a lot quieter. This, by the way, this one was made by General Electric. Let's plug a third one in here. This is made by a company called Simply Conserve. And these are the bulbs that our local PUD was handing out to people. And this one's pretty noisy. So there's just some examples of things you can do. Now I'm going to share my screen again here. And we're going to look at an SDR. And what I have here is I have an SDR dongle here. This is actually an SDR radio you can buy. They're about $25. It's got a USB port on one end. It's got a connector for the antenna on the other end. And I'm going to plug it in. And I'm going to hook it up. And I'm going to share my screen again. Let's see here. So let's go to show. And Chris, can everybody see my screen again?
Yes, we can.
Okay. And what I'm going to do is this is SDR Sharp software, and we're looking roughly at the 10-meter band. So right now, I've plugged the radio into the USB port, and what I'm going to do is I'm going to go ahead and turn it on. And all of a sudden now you can see signals that are being picked up by this loop antenna. I don't know if you can see this antenna very well. Basically, it's a coat hanger on the end of a long stick, and I've got a common mode choke on it, and I can actually move this around the room, and you can kind of see the noise floor go up as I move this thing around. And I'm going to put this thing right next to my laptop. And what do you see? But what do you see on the screen, right? You see all the noise, and look at all those little noise spikes, and look how high the noise floor goes up. It goes up by probably 20 dB when I get close to my laptop. If I go next to the laptop screen, now I've got the antenna very close to the screen, and look at all that noise, right? So this is just a little simple loop antenna. Now I've got right next to me over here, you can't see it, but it's off camera, but there's a printer. I'm going to put this on top of the printer. And what do you see? Look at all those little spiky noise things that are coming out of the printer. And these are all noise sources. This is the side of the printer. Well, I can tell where the noise is on the printer just by putting the antenna and pointing it at the printer. I've got a television here that's turned off right now off to the right of me, or off to the left of me, excuse me. I'm going to put it on there. Well, there's no real noise that I can see. Nope, that looks pretty quiet. I've got some LED light bulbs up here. And look at that. Look at the little noise spikes that have come up when I go next to these LED light bulbs. And you can see them kind of going up and down there a little bit. So this is another thing that you can use using an SDR. So with that, let me go back to stop showing my screen and get rid of that. And let me let's go back to here again. Hold on. So there we go. Now it's time for questions. So I'm going to turn it back to Chris. And Chris, you've got it.
All right. Thanks a lot, Mike. Great presentation. The demonstration was incredibly helpful. So we'll start with questions. And just a reminder, we'll be recording all the questions as well. So if anybody needs to drop off, we will be capturing them. First question. What is the range and distance of noise emitted by the wall warts?
Well, it's probably within about 10 or 15 feet, but it depends on, one thing these things have is they have cords on them, right? Sometimes these cords wind up acting as antennas. So a lot of people will take them, they'll put a little ferrite bead or wrap this around a ferrite right here at the beginning to keep this from becoming an antenna. But it can be 5-10 feet away. So if you've got a bunch of these in your shack, and especially they add up, right? So you get one that puts out a little bit of noise, you got 2 or 3 of these, and it becomes cumulative. So the best thing to do is to eliminate them if all possible. You're not going to get this if your next door neighbor has one necessarily, unless it's really, really noisy. But once again, ferrites sometimes help these. One thing it helps too is if you're forced to use something that is noisy, is to build a Faraday cage around it. One thing I've been able to do to keep RF out of my AV receiver that I use for my surround sound in my living room is I actually built a Faraday cage out of half-inch hardware cloth. And when I'm running a radio contest and I don't want my wife yelling at me, I will actually go out and put this Faraday cage over that piece of equipment, and it keeps the RF out of that from me interfering with it. And that's often helpful, so it works both ways. Next question.
How close can high voltage transmission towers be before they start to affect ham noise levels? I have a couple of them about 200 yards away.
That could be problematic, and it depends on if they're really defective or not. A lot of times in the old days, the power company, especially on the really high voltage transmission lines, they would go out and clean the insulators off, right? The insulators build up dust. The dust can have all kinds of who knows what in it, right? Including metals. And eventually the insulators build up enough dust on them. It gets wet, and the next thing you know, you've got an arcing path. Once you've got an arcing path, you've got a carbon path, and then it can continue to arc forever. And in the old days, the power companies used to be a lot more vigilant in cleaning the insulators on these. I am lucky in the fact that the only thing I have to deal with around here is my normal, single wire 7200 volt line, and I don't have anything near me. And I have had friends of mine that are hams that have lived pretty close to power lines up to about 128 kilovolts within I think 500 yards of his shack, and really has not had any noise problems. But it really varies. If it's bad, it could be a mile away. I did have a noisy transformer that was about half a mile from my house, and I tracked it down to a particular transformer that was arcing internally a little bit. And so it could be a ways away. It depends on just how big the problem is.
Next, have you tried a loop on the ground as an antenna to improve LF-RFI?
Well, that's one of the things you can do, right? They have what are called beverages on ground. Any way you can get down to and use the ground as a huge absorption source and have an antenna with lower gain to help get rid of the noise. That's what one of the reasons the beverage antenna works well is it's fairly low to the ground. They have actually what are called beverages on ground, or called BOGs, and those work very well too.
Can you talk a little bit about the noise created by home solar panels and inverters?
Yeah, I have a 5 kilowatt solar panel array here at my house that I use here in Northwest Oregon, and those are a big problem right now. If you've I've heard from W1RFI at the ARRL labs, they are constantly working with the manufacturer of these to try to get rid of the noise problems. And my understanding is the ones that have the individual inverters on each panel are much more of a problem than the ones where you have a separate inverter. I'm lucky here that my inverter is in my garage. My garage is the part that faces my shack is underground, so I've got a ground separating where my inverter is. But a properly designed inverter will not be noisy. But of course, there's lots of different inverters out there, and if you've got a noise problem after an installation, contact the manufacturer. If your neighbor's putting one up, find out who they are, contact the manufacturer. And if you've got any questions about it, contact the guys at the ARRL lab, and they'll be glad to help you with that. They've really become experts, and they have worked with several manufacturers to try to get them to clean up those, especially the ones that I mentioned with the where there's an inverter on each individual panel. Those are more of a problem than where the inverter is separate by itself and farther away from where your shack could be.
Why do vertical antennas typically have more noise?
Well, because man-made noise is vertically polarized. That's one way to put it. And they also, as I mentioned, they're omnidirectional. So they're picking up noise and signal from all directions. And anytime you can narrow that beam width down by using a Yagi, you're not only going to increase the level of the signal, you're going to decrease the level of the noise. But a lot of it has to do with the fact that man-made noise is mostly vertically polarized, and a vertical antenna is by nature vertically polarized.
Do you know if there's any chance that the LED lighting noise generator problems will be addressed by the FCC?
Well, here's the deal. A lot of the FCC regulations don't really affect anything below 30 megahertz. So just because something says that it's FCC type accepted, Part 15, doesn't necessarily mean it's not going to be noisy in the ham bands, right? They're more interested in stuff that are affecting the public service bands up in the VHF range, the UHF range, and they don't really care too much about what happens below 30 megahertz. So the quick answer is probably not. The best thing you can do is to use RFI, not only generation but susceptibility as a shopping point. If you've got a problem, contact the manufacturer and tell them what your issue is, and hopefully they'll work with you. I had a big problem here with a particular Samsung television that I bought back when the new sets came out in 2009. And I noticed every time I got on 40 meters, even with lower power, it would change channels on itself. And I actually got a hold of Samsung, and they actually sent an engineer to my house from Southern California. They flew him up here to see what my problem was so they could take that information back to the factory. And they may have fixed the problem since then, but they fixed it on mine by getting rid of unplugging the touch sensors in the television. I wasn't using them anyway, but that was their engineering solution, was to take away the touch sensors. But the big thing is to work with the manufacturers if you can, and have them help solve your problem.
Have you used any of the Philips brand LED bulbs that are supposed to be used for RF sensitive areas?
No, I haven't. I do like everybody else does. I buy my lights at Home Depot, and that's one thing I can say. If you do buy a light and it does cause a noise problem, take it back and tell them why you're taking it back.
With the SDR dongle, when you said you hooked it up to an antenna, was this antenna outside your home or an antenna connected to the laptop inside?
It depends on if you're trying to see what I was showing you. I was hooked up to this this little internal antenna. But if you're trying to characterize your RF environment as seen by your outside antenna, you want to use your outside antenna. One thing that'll do is if you do have a noise source, especially if you're hooked up to a Yagi, you can actually rotate the antenna around and find out what the direction of the noise is coming from. As I mentioned, on 40 meters, I can point my antenna towards the city of Portland, which is really the only thing between me and 25 miles down the road. And my noise floor will on 40 meters will go up by at least an S unit. And with an SDR, you can physically see that as you point it over there. So that's one way you can do it.
And how is the coat hanger antenna wired to the SDR?
What you can't see here is it's got an SO239 connector that's attached to a coax. And let me unplug it here so I'm not using it anymore. So here's the SDR, and I've got a little SMA to BNC, BNC to to a PL259, and I've got a little ferrite choke on here to make sure that anything I'm picking up is not coming out of the radio going into the SDR or being picked up on the coax coming on here. But I think it's about a 15-foot long piece of RG58. And the thing is, I can take this and throw my laptop in my car on the seat, put the antenna out the window with the dongle attached to it, and rotate this around and try to get a bead on where the noise is coming from. You can see I've got the center connection on one end here, and here's the bottom end on this side. As I rotate it towards on here, this winds up being directional this way, kind of like a Yagi antenna, right? This is considered to be almost like the reflector part, and this is the driven element part on this side. So that's the way the little small loop antenna works. We used to use these a lot for 10-meter transmitter hunts back in the day. We used to drive around the city and do T hunting on 10 meter AM back in the early 70s, and these are exactly the type of antennas we used for that. They're pretty directional.
Do you have any recommendations for power supplies that can replace the multiple wall warts?
I can tell you that as a matter of fact, a friend of mine had a problem with his power supply. I'm not going to tell you which brand it was, but it's 3 letters that start with an M. And it was doing some strange things in his radio. And he brought it over here and said, "Here, take a look at this thing." And I put it on on a load and attached the oscilloscope to the output under load, and it was putting out probably almost a volt of noise. And when it was turned off, it had big spikes in it. It was putting out RF hash. You could actually see it on the oscilloscope. And so I would say that if you can, if you want to have the best thing to do is to not buy a switching power supply, buy a linear power supply, like the old Astrons that have a heavy and have a transformer in them. Those things will be quiet. However, the ARRL published in QST magazine a few months ago. Chris, maybe you remember what month it was. I think it was may have been 2 months ago. They actually did a review of several of the switching power supplies, and I believe all the modern ones that they had were fairly quiet. I don't remember exactly which issue it was, but look at your QST magazines from a couple of months ago, and they've got some great reviews where they're actually checking the noise of several modern switching power supplies, and they found some that were pretty darn quiet. I have one that I use on my FT450 that I use for portable use, and I've measured it, and it's very quiet. It's got no more than 5 millivolts of noise, both radiated and conducted out through the DC wiring.
Okay, we have time for just a few more questions. Wouldn't your house wiring become an antenna for wall warts?
It certainly can, right? You're not only can the cord for the unit itself, it can also radiate that back into your house wiring as well. Absolutely. Unless you have a shielded cable in your walls, and that's probably not too likely.
And what do you use to view the signal from the SDR dongle if you're using it away from your shack to run down noise from electrical devices in your home?
I don't quite understand the question. I guess you would have it attached to the USB port and have it on a portable small, hopefully not a huge big laptop like I'm using here, but a smaller laptop, or an SDR player, one of the other, obviously the more equipment you get, the advantage of a small dongle is that it gets its power off the USB port. You don't need a separate power supply for it. Once you get into the SDR play type situations, they require external 12-volt source, and you have to plug it into your cigarette lighter plug, or make up a special cord for it. But like I mentioned, it's just it's a fairly small unit with a small antenna port on one end, USB for power on the other end. That's really all that are in there. The disadvantage, by the way, of something that's this small is there's not a lot of filtering in them. So sometimes you get a lot of what are called artifacts. There'll be stuff that's generated internally within the radio because there's just not a lot of filtering in here. If you really want to get serious about it, I don't recommend the $20 one, but if you want something to just play with and have some fun and go around and look at stuff, this works just fine.
With a vertical antenna,
go ahead.
With a vertical antenna, is it best to put the ferrites closer to the antenna or to the transceiver?
Well, if you're trying to use them for common mode noise, you want to put them as close to the input or the transceiver as possible. Because once if you put it close to the antenna, you can use it as a common mode choke there to try to get the signal out. But the problem is you want to have not only one there to provide the correct impedance, right, like a balun, but you also want to have maybe a second one that is closer to the radio, so to get rid of noise that gets picked up on the feed line after that first coaxial choke. So sometimes you want to have them, if you really want to get serious about it, I've heard of people that have one at the top at the antenna, halfway down the tower, and then one that's very close at the radio. I've actually got one that's literally on the output of my amplifier. I've got a toroidal choke there and that keeps anything that's even within the shack before it gets into the amplifier and then finally into the radio. I've got another one at the input to the radio. So I've got probably, I bet 20 or 30 RF chokes that are in my shack. I've got them on almost every line in there. And by the way, my shack is inside of a pole barn building that's got a metal roof and metal walls on it. So essentially my shack is inside of an RF Faraday cage. But obviously not everybody has the ability to do that.
On 80 meters, there are many nights when everyone on the net is complaining about the static noise. Are there just times when there is noise that is not man-made?
Well, obviously, a 80-meter noise is mostly atmospheric. I've got a very high 80-meter noise level here, and it's primarily caused by power lines. I have yet to really track it down because sometimes it's there and sometimes it's not. But I've had to use all these mitigation techniques that's why I made this presentation up, right? Was I've had this exact same problem myself. And 80 meters I found is one that's really, I think, prone to power line noise as some of the other bands. And that may be where it's coming from. But obviously there's different atmospherics conditions that it can occur. Well, you'll have more noise on 40 meters, less noise on 80 meters, and maybe more noise on 160 meters. It really kind of depends on what's going on with the atmosphere, what's going on with propagation.
Does a ferrite choke replace a common mode choke?
They're consider them to be the same thing. You're using a ferrite choke to be a common mode choke. So the part is the ferrite choke, and the way you're using it is to get rid of common mode noise.
And are desktop computers less noisy, more noisy than laptops?
And the answer to that is yes, because a desktop computer will generally have a metal case around it that you can ground and tie that into your central point ground and tie the case to your ground bus that you have in your shack to ground everything together, or your central grounding point. I have a small contest station that I have, and I've actually got 4 Dell desktop computers that are all literally right with the radios that I use for logging. I use one as a PAN adapter, a PAN adapter. I use one that powers anyway, I do graphics on the side for looking at spots and whatnot. That's a separate computer, and I have the cases of those are all tied with bus line over to my central point ground. So you can shield those better than you can laptops. A lot of laptops have plastic cases, and it's really a lot harder to provide that shielding.
Okay, our final question for today. How can I combat neighborhood LED streetlight noise? Can the city replace them or add filters?
Well, that's really a tough one. It depends on how large a city you're in and how big of problems they are. I think that they are definitely generating noise. Like I said, my noise level here when I aim my 40-meter Yagi at the city of Portland has gone up here in the last couple of years since they started replacing all the street light noise. The big thing is to let the city engineers know about it, and then find out who their manufacturer of light bulbs is. And if you have to, get a hold of the manufacturer yourself and let them know what the problem is. But work through the city engineering department. It can be a lot easier. I mentioned I live in a rural area, and so I'm in very good terms with the local PUD. It's a smaller PUD. If I was working with a large utility in a large metropolitan area, they don't really care about you. But in a smaller community, you're going to have a lot better luck with them than you are in a larger city. I'll just put it that way.
Great. Thanks so much, Mike, for taking the time for the presentation today and for answering all these questions.
Certainly.
And also thanks to Icom for sponsoring today's presentation. Just a reminder for everyone to visit our Learning Network page for a schedule of upcoming presentations and past recordings. You can go to ARRL.org and click on the webinar link under the slider, or do a search for the Learning Network. And our next session is a W1AW antenna farm presentation from our station manager, Joe Karsha, NJ1Q, and that's on Tuesday, May 18th at 1 p.m. Any final words today, Mike?
I just want to thank you and thank the ARRL for giving me the time here to present, and hopefully the audience learned something. We're always here. We're always here to learn. We're here to learn. We're here to teach. The people have been around a long time like us, and we're also here to learn. And I really appreciate the ARRL giving me the opportunity to present here to the crowd here this afternoon. Thank you.
Great. Thanks, Mike. And a reminder to reach out to our technical information service if you have individual questions.
Wonderful guys.
And you can reach them from our website. You can just search for technical information service. They have a lot of information online, and also phone and email to reach out to them. So thanks again, Mike, and thanks everybody for joining us. And that's all for today.
All right. Thank you.